Okay, so welcome all to the fifth week of problem solving sessions. So, since the deadline for week 4 assignment has recently passed, so we will be discussing the week 4 assignment solution today. And since this is an interactive session, I will encourage you to keep a pen and paper ready with you. And first, I will give you some time to solve it and paste the answers in chat box, and then we will see the solution. So let's start with it. I hope you guys can see my screen.
Yes, sir.
Okay, let's start with the first question. So the question is there on your screens, and you need to find the ratio of input and output voltage in this question. Please try it out. Okay, so let's see how to solve this question. Now, one very easy mistake that any person can do in this question is to assume this node as a short circuit node. Sorry, open circuit node, because it looks that way that this is open circuit. However, and you have to keep in mind that in the question it's given that a current I1 is flowing through this node. That means there is some circuit at the right side of this node this that has not been mentioned in the question. So keep in mind of that. And now, if we solve this question, what we have is uh, so in this loop, what we have is Vi is equal to 2k I1, and in the second loop, we have if you write the KVL on in this loop, you have V naught minus the two 1 kilo ohm resistors having current I1 through them, that gives minus 2k I1 is equal to 2 times Vi. So if you substitute 1 in 2, like 2k I1, if you substitute over here, you get V naught by Vi is equal to 3. Now, had you assumed that this is an open circuit, and in that case, there would have been no current flowing through this, and you would have written 2Vi is equal to V naught, which would have resulted in V naught by Vi is equal to 2. So, this would have been wrong. So, please be careful while solving these kind of questions, and see like what all notations have been, what all current and voltages have been given in the question at each branch. Any doubt in this? Okay, so if there is no doubt, we'll move to the next question. Now, here, what you need to find is you have been so in this question you have a network of resistors and current and voltage sources. You have been given the voltage difference between node A and B, that is VA minus VB, as 8 volts, and you have been asked what is the voltage difference between node C and D. Please try to solve this question now. If you're done, you can paste your answers in the chat box. Okay, so let's see how to solve this question. Now, you need to this might become a little complex if you try to solve it algebraically and try to put KCL, KVL at each branch and node. So what you need to see in this question is that what you need to understand is the Kirchhoff's current law is basically the law of conservation of charge. Okay, now that can be applied either at a node or at a part of circuit also. So in this case, if you try to apply the Kirchhoff's current law in this part of the circuit, so whatever current, all the current that is flowing into the circuit will be equal to the current that is flowing out of the circuit. Okay, so now you have been given that VA minus VB is 8 volts. So if 8 volts is applied across 2 ohm resistor, the current that is flowing in this direction is 4 amperes. And assume that VC minus VD is VCD. So VCD will create a current of VCD by 1 ohm across this 1 ohm resistor, and this 5 ampere current source is also there. So if you try to apply the KCL in this particular section of the circuit only, you will get that 4 ampere plus VCD plus 5 ampere, because all the currents are flowing in one direction, is equal to 0. So from there you get VCD as minus 9 volts. So basically, VCD, if you assume that was current, it is minus 9 amperes, and since it's flowing through 1 ohm resistor, so it's minus 9 volts. VC minus VD. Any doubt in this? So this is the correct answer.
Sir,
Yeah.
sir, how can we think in this way? Suppose we are asked in this question VC minus VD. So how
Yeah.
can we think in this way that this is the solution? This may be the solution.
For this, you need to practice a lot of questions. And when you practice, and let's say you solve back exercises or solve solved questions of previous year things. So in those cases, you keep on getting across these kind of cases where such things can be. For example, now you know that the KCL can be applied for any sort of circuit. What you need to do is at least you need to cut across the circuit so that it cuts. You can't just say I mean, you need to. basically see that okay, you are considering the cuts that are there that are across the circuit. So this kind of I mean uh, so this kind of cases like once you get across one of it, so in future you will just remember that okay, yeah, this something of this sort can be applied whenever you see something like this. And yeah, so only solution for that is a lot of practice. And yeah, as you practice more, you will get to know more and more such kind of cases. And yeah,
Okay, sir.
so let's move to the next question. That is the third question. So here you need to find the current through the resistor R2. Please try to solve it and paste your answer in the chat box. And what I will advise is even if you see that questions are straightforward, still you try to solve the questions because in circuits, questions of circuits, what you mainly want to achieve is accuracy, a lot of accuracy, because you deal with a lot of equations, algebraic equations, and you can do a lot of mistakes. So please try to solve these questions till end and get to the correct answer, so that once you are having sufficient amount of practice, the silly mistakes and the chances of silly mistakes occurring will become very less. So please try it out and write the answer in the chat window. Okay, so let's see the solution. So here, what uh, is there any doubt? Okay, so let's proceed. So let's say the current flowing in this branch is IR2. So in that case, if you try to apply KCL at this node, so you have IR2 going out of this branch and zero point zero 0.04 times Vx coming into this node. So there will be so the current that is flowing from IR1 from KCL, you can write it as IR2 minus zero point zero 0.04 times Vx. Now, if you apply the KVL at this complete mesh, so what you will get is 60 volts minus 5 times the current flowing through this 5 ohm resistor, that is IR2 minus zero point zero 0.04 times Vx, minus 3 times IR2. So, sorry, yeah, minus 3 times IR2 is equal to Vx. Now, Vx can also, since IR2 is current flowing in the series of 3 ohms and 5 ohm resistor, so Vx can be written as 5 times R2, 5 times IR2. So if you substitute this, so you get a equation that is only in terms of IR2. If you solve this equation, you get IR2 as 5. Any doubt in this? Okay, so let's move to the next question. So Here, basically, you need to find the input resistance from this node, that is V by I, that is equal to Rn. So please try it out. Okay, so let's see the solution for this. So if you look at the network that is given, so you have IB flowing from 9 kilo ohm and 1 kilo ohm branch, and 99 times IB flowing from current controlled current source from the top, from top. So if you try to apply KCL at this node, so what you will get is 100 IB, that is 99 IB plus IB, plus I plus the current that is flowing through this 100 ohm resistor, that is equal to uh, V by 100. So so you get this, equation. Now the voltage, since this voltage is applied across this 10 kilo ohm equivalent resistance also, so from there you can see that IB will be equal to minus of V by 10 kilo ohms. So if you substitute this into this equation, you get equation between V and I. So from there you can find the ratio between V and I, that comes out to be 50. Any doubt in this? Okay, so let's move forward.
Sir,
Yeah.
sir, in the previous question, it was not explicitly given that with respect to what this V voltage is defined. So then, in this type of question, how can we assume that?
Okay. Yeah. Uh, yeah. Correct. So it should have been mentioned that this is ground, or this is 0 volts. Correct. So it should have been mentioned. Okay. So we'll take note of this and see if we can edit the marks given on this question. Okay.
Okay, thank you, sir.
So now in this question, you need to apply the nodal analysis on this particular circuit, and you need to find uh, the two equations in terms of V1 and V2, and accordingly you need to find the coefficients of the matrix from A11 to A22, and you also need to find B1 and B2. Please try it out. Okay, so let's see how to solve this question. So, in case of applying nodal analysis, you should keep in mind that whenever you have voltage sources in nodal analysis, you can consider them to be a part of a super node. So as we discussed a few slides back, that the KCL is not only limited to one particular node. You can apply KCL to any part of the circuit. So super node also is the same concept. So if you apply the KCL considering these two nodes combined, so what you will get is, so whatever current that is flowing inside this super node is equal to the current that is flowing outside the super node. So if you apply KCL accordingly, you will have V1 by 10 flowing in this direction, then V2 by 5 flowing in this direction, and V2 by 2 flowing in this direction, and 7 amperes current source flowing again in this outside the supernode. So you get this equation. So from here you can simplify it and get the equation of the equation in this form. Now, since you have assumed the supernode between V1 and V2, so from there, since there is a voltage source between that, so V1, V2 minus V1 will be equal to 6 times Ix. That is the value of the voltage source. And Ix, you know, as minus V1 by 10. So if you substitute this in the above equation, you get V2 minus V1 as minus zero point 0.6 times V1, and from there you get zero point 0.5 times V1 plus V2 equal to 0. So you have equations 1 and 2. So from there you can get the values of A1 to A11 to A22 and B1 and B2. Now also so there was a problem in solution. So these solution is not these solutions are not unique. So let's say if you try to multiply the solution by minus 1, so you get some different value. So the signs of these coefficients will be reversed. So yeah, this will be updated in the assignment solution that has been provided. So yeah, any doubt in this?
Sir, equation V2 minus V1 is equal to minus
Yeah.
0.6 V1. Sir, after that, how you get this 0.5 V1 plus V2 equal to 0?
Sorry, it is 0.7. No, no, it is 0.4, not 0.5. So, yeah, my bad. It was a computation calculation mistake.
It's a minus 0.2.
Yeah, correct. Minus 0.4. So, yeah, let's move to the next question. So, here you have been given a network in which it is said that the power loss across this load resistance RL is of 18 watts, and from that you need to backtrack the value of V naught. So, please try it out. So, let's see the solution of this. Now, first of all, this current, the voltage controlled current source is related to this voltage across 4 ohm resistor. Now, for that, to find this, you can apply simple voltage divider. So, first of all, you need to find its parallel combination that comes out to be 1.2 ohms, and from there you get Vx as equal to 4 by R, basically Rx upon Rx plus Ry. So, from there you get Vx equal to 4 by 5.2 times V naught, and so now 8 times this Vx is the current that is flowing in to this branch. So now, since 5 ohm resistor is in series of an ideal current source, so this 5 ohm resistor is of no value in this circuit. Now, uh, if you see after this, you have a current division that you need to apply in these two branch to get the current flowing through the RL resistor. So IRL is 2 ohms divided by 2 plus 12 ohms. So that comes out to be 2 by 14 times whatever current that was flowing into that is IRL. Now power is I square RL times RL. So from there, if you equate this to the given power loss in the question, that is 18 watts, you get V naught as equal to 3.4125, and the closest to this is this C part. So this is the answer. Any doubt in this? Okay, so let's move to next question. Now you need to find using nodal analysis the values of V1 to V4. So I will give you around 1 minute. So please at least write the equations that you need to form for the nodal analysis, and you can solve this later, or maybe you have solved it as this assignment's deadline has already passed. Okay, so let's see how to do it. Now again, you have two supernodes that are being formed in this question. So for those two supernodes, what you will have is the first one is V3 minus V4 is equal to 3Vx, and Vx is nothing but V1 minus V4. So from there you get V3 minus V4. So from there, if you solve this and simplify it, you get the following equation as equation one, and simply this another supernode, you have V1 minus V2 as 20 volts. So this is the second equation that you get. Now, if you apply the KCL at KCL at supernode 1, 2. So from there you get V1 by 2 that is flowing outside the supernode. Then V1 minus V1 minus V4 that is again flowing outside this supernode, and V2 minus V3 that is again flowing outside this node. V2 minus V3 by 6, and the 10 ampere current source that is pumping current inside this particular node. So from there, and if you simplify it, you get this the third equation. And similarly, if you apply the KCL at the next supernode that is found by node 3 and 4, so from there you get the fourth equation. Now you have four equations and four unknowns, so you can write in the matrix forms and by the row and column transformation or whatever method you find convenient, you can find the values. So these are the values for the equation for the question. In doubt in this? So let's move forward to the next question. Now here again, what you need. So again, in this question, what you need to do is you need to find the. So in this question, what you need to do is you need to find the equations, the current you need to apply the KCL, the nodal analysis at this circuit, and you need to find the values of the coefficient of values or in the entries in the matrices, that is the G matrix and the B matrix. So please try it out.
Sir, this is Krishna Swami.
Yeah,
Hello.
yeah, yeah.
I solved the problem, especially in the no, digit precision after point 0.166. I put 0.16, then in the answer it is 0.1666 is there. What is the difference? I
Okay,
don't know.
so that thing also will be taken care of. We have,
If I raise the question in the forum, there is no any answer I'm getting. Then what is
uh,
the purpose of raising the question is there?
yeah, that's what
If
we
someone
are.
is replying, na, we will raise the question. Na. Still,
Yeah,
from
so we
38
are.
onwards, no one raising the question. Sorry, well, no one reply to the questions which is raised in the forum.
Okay, we will take care of that, and this thing is noted and has been informed to the professor, and that thing will be corrected.
Thank you, sir.
Yeah. Okay, so let's see the solution for this. Now, this is straightforward. There is no any no voltage source, so you need to apply KCL at the three nodes. And if you do that, you will get the values of the coefficients of the G matrix and as well as the B matrix. So you just need to make sure that you don't do any calculation error in this. And yeah, so this is a straightforward question. Any other doubt in this apart from the precision? Yeah, the solutions will be uploaded. So you have the uh, in the section in one of the sections in the course web page. You have the link to these live sessions, right? The live sessions. The material that we are presenting in this live sessions as well as the video. So from there you can get the solutions of these assignments.
Sir, I have a problem that across B1, please see the question, please.
Yeah.
Across the node B1 and B3, there is two branch that is 4 ampere element and 6 ohm. So
Yeah.
what is I am facing problem in that.
Okay. So for that, so let's say when you are applying KCL for node one, so you just need to make sure whatever current is flowing into or flowing outside this node. Okay, so in that case, so what you will have is V1 minus V3 by 6 ohms. So here you have it as V1 minus V3 by 6, and the other currents that are V1 minus V2 by 3 and V1 by 4, and the 6 ampere that is going inside inside this node, and this 4 ampere current that is flowing outside that node. Then again, that on since you are writing it on RHS, it becomes minus 4. So you need not to worry about that there like
To
to what
consider
node.
both, we have to consider both.
Yeah, correct, you have to consider both the currents since both the currents are will be affecting this node, right? So
Okay,
you
okay.
need. So had it been voltage, then the parallel thing is so in parallel they are the same. You need not to consider. But for the case of currents, if they are in series, they should be equal. While the currents in parallel will be added.
Okay, okay.
Yeah, and when you are again when you are writing the KCL for the uh, node 3. So this V1 minus V3 by 6 that you have over here will its polarity will be reversed. So you in this case you will have V3 minus V1 by 6, and the 4 ampere that was flowing outside from the node V1 is now flowing inside the node V3. So that also, so in this case it was negative, in this case it is positive. So yeah, is it clear now?
Yes, sir. Now got it. Okay, thank you.
Okay. Now you have this question. So you need to find out how much power is being delivered by the 50-volt voltage source in the particular circuit. So please try it out. So let's see the solution to this. Now, it will be easier if you convert this. So, in order to solve this, since you need to find the current through this 50-volt voltage source, in order to get the power that is this voltage source is delivering, it is easier that if you convert this through source transformation into a voltage source, and these resistance into their equivalent resistance. So if you do that, the this particular terminal, so across these two terminals, you get a voltage source of 200 volts, and the polarity, how you need to check it out is, so let's say you detach it over here. So what you have is uh, 4 ampere current that is flowing in this direction, and 50 ohm resistor. And since this flows through this 50 ohm in the upward direction, so the voltage that is developed is 200 volts, with the topmost terminal is a negative voltage, and the lowermost terminal is positive voltage. So from here, it can be converted into a 200 volt voltage source with the polarity that is shown in the figure, and in series of that, a 50 ohm resistor. And in the other part of the right part of the circuit can be written as the equivalent resistance. So that comes out to be 50 ohms. Now, here you can easily apply the Kirchhoff's voltage law in this node, sorry, in this loop, and from there you get the current that is flowing from 50-volt voltage source as 2.5 amperes, and since it's flowing from the positive terminal of this voltage, positive terminal of this uh, voltage source. So it is actually delivering power. So the power delivered by this 50-volt voltage source is 50 into the current that comes out to be 125 volts. Any doubt in this?
Clear.
Yeah. Uh, Krishna Sami, is there any query in this?
No, sir. Clear, sir. Clear, clear.
Yeah. Okay. So now let's move on to the last question. So you need to find the current that is flowing in this branch. Please try it out.
Sir, which book you are recommending for this subject, sir?
You can go for Hyatt and Kemerly, linear circuit analysis. That has got a lot of questions and a lot of solved examples, so that will really help you clearing the concepts.
Thank you.
Okay, so let's see how to proceed with the question. So, what you should do in this question is now you can see that this complete uh, thing is a short circuit, so it will have same voltage, and the other unknown voltage source will be at this node that will be equal. So let's call this complete node as VA, and let's call this node as VB. And since there is a 8-volt voltage source between this node and this node, so this will be just equal to VA. So this will be VA plus 8 volts. So if you annotate the nodes accordingly, then you can use the KCL KVL. So you can see that what are the currents that are flowing through each branches. So since all of them are 1 ohm, so now this 5 ohm resistor again doesn't makes any sense in the circuit, because this is in series of ideal current source. Now, what you have is so in this node, in this direction, you will have a current flowing, that is VB minus VA. Now, I'm dropping the 1 ohm as that will be, and that will make the thing a little messy. It is already messy, but it will make it more messy. So now, again, in this branch, you have VA plus 8 minus VB, and in the lower branch, you have so this is VB, this is VB minus 8. So the current that is flowing is VB minus VA minus 8. So from this, you can calculate. So if you apply the KCL at this node, you get one equation of the one equation of VB minus VA. Now let's try to apply the KCL at the other node. So the currents that are flowing. So you have okay. So you have in this branch you have current as 1 plus VB minus VA, and so what will be the value of I? That will be the current, that is 1 plus VB minus VA, and this current is VB minus VA minus 8. So the total current that the I is equal to 2 times VB minus VA plus 1 minus 8. So if you do it. So actually, this is the direction of current is in the opposite direction. So minus I is equal to 2 times VB minus VA plus 1 minus 8. Now VB minus VA, while you applied the KCL at the central node, you got VB minus VA as 4. Now if you substitute this in this equation, so you get the value of I as equal to minus 1. So yeah, this was a little haphazard question. You needed to uh, use some tricks or some clean algebra to solve this. Any doubt in this? Okay, so if so, this was it from your assignment 4. So these were the questions in that, and the errors that were there in the solution that has been noted as, and has been identified to the professor of the course. And any other doubt? Okay, so if there is no other doubt, we can end the session. Thank you for attending.
Thank you, sir.
Thank you, sir.